Hi everyone, today's lesson is going to be on distributive property. Before we do the property, let's focus on the visuals involving area models. So we're writing expressions that represent the area of each rectangle. So as a reminder, area is equal to length times width. And honestly, in a rectangle, I always interchange width and length all the time, back and forth. There's no consistency with me. So in this one, they're simple. They're both numbers. So you should know that area is equal to 4 times 5. And yes, it's 20, but we're trying to find the expressions. For number 2, same idea, length times width. So this is just going to be area is 7 times m or 7m. And in this one, it's going to be area is equal to 3a or 3 times a. Same thing. Just going to ignore this one just because you haven't done exponent rules for variables, so just going to ignore that. And now this is changing it up a little bit. You see that there's multiple rectangles, so you're going to find the area of the pair. So how would you go about doing this? Well, you can find the area of this, you can find the area of this, and what would you do? You would just add them together. So you're just finding the sum of them. So the area of this one is 4x, or 4 times x, and the area of this rectangle would be 3 times 4, because if this is 4, then this is to be 4, so this would be 12. All right, so your final expression would be 4x plus 12. And I'm sure you can figure this one out after doing that one. This area of this rectangle is 7a, and this one is 9 times 7, which is 63. So the total area of this is 7a plus 63. And remember, these are unlike terms, so you cannot add them. We don't know the value of a. We're just trying to find the expression. And lastly, over here, now you have you're trying to find the area of the entire rectangle. So this is going to be 5x and 7 times 5. Oops. Which is 35. So you get 5x plus 35. Can anyone figure out what the length of this entire side is? That is 7x plus 7. So what you're essentially doing over here is actually doing 5 times x plus 7. And you'll see why this is really important. Over here, we'll do it. I'll tell you the area of x times x is x squared. And then the area of x times 12 is 12x. So this would just be x squared plus 12x. And just like that one over here, the length of this side over here is going to be x plus 12. So if you're trying to figure out how you're writing it from the length and the width like that, you would just do x times x plus 12. And these problems over here are what you're going to be doing today. You're using distributive property. And if you want to draw the shapes, you're more than welcome to. But that's just going to end up becoming really tedious after a while if you don't want to do that. But this is what you're going to be doing. You are actually going to be simplifying two terms like this, 5 and x plus 7, or not x and x plus 2 because you haven't learned x times x yet. All right, so that's where we're going towards today, and talking about the property for that. Your distributive property, again, is another way of writing equivalent expressions, but just in a different format. So the actual property says this, all right, a property that can be used to rewrite an expression without parentheses. So your problems are going to be where you're going to have a number or on the outside times b plus c, which are just integers. Or you're going to have a number on the outside and you're going to be multiplying it by a subtraction of two either integers or a variable and an integer or whatnot. Okay, so let's just do that. All of this can get really confusing. I'll explain what that means when we do a problem. So let's just discuss the mental math aspect of it. A lot of the times when you see 3 times 102, most of you will go into doing this without a calculator. But why? This is actually a completely inefficient way of doing it. Mental math-wise, this would not be the way to go about doing it. So how can you break up 100 to easy numbers? We can break up 100 by doing 100 plus 2, correct? And mentally, all you're doing is you're breaking up that 100 and 2 to 100 plus 2. Everyone mentally here can do 3 times 100, which is 300, and 3 times 2, which is 6. And that is just 306. This is a really wonderful way of doing math. You don't need to just do long multiplication all the time. This works with subtraction too. What if you have something like 3 times 97? That would be broken up into what? 3 times 100 minus 3. So this time you're going to do 300 minus 9. And you can mentally do all of this. We'll get you to 291. All this is saying is you're multiplying that 3 to 100 here and 3 to 2 here. And that's how you're getting these two numbers. You're multiplying 3 to 100 here and 3 to a negative 3 here. Don't forget that sign that goes with it. So 300 minus 9 is 291. That's much, in my opinion, without a pen and paper, this is easier to do. What about with decimals? Don't confuse the decimals. Same thing. How would you break up 4.1? You would break it up by doing 4 plus 0.1. So 6 times 4 is 24. 6 times 0.1 is 0.6. And then just the sum of those two mentally would be 24.6. No, like long multiplication. This is using numbers to do distributive property. All right. How about when you have expressions now? All right. So equivalent expressions are two or more expressions that represent the same algebraic expression. So use the distributive property to simplify each expression. So we talked about over here when you're multiplying one term to a term with more than one item, you have to break that up. Over here, we cannot combine x plus 8 and get 8x. They're unlike terms. We just talked about that. So you're going to have to do 7 times x and 7 times 8. This is similar to the rectangles that we just did. Like this. 7 and x and 8. So over here, 7 times x is 7x. 7 times 8 is 56. So instead of doing all of that, all you're doing is the math over here. 7 times x is 7x. 7 times 8 is 56. And if drawing the figure helps you out, there's nothing wrong with this, but you're going to be seeing this type of distributive property used in algebra classes and pre-algebra quite repeatedly. Right? Let's do another one. So this time it's going to be 3 times y, and I really recommend drawing these loops. It's a reminder every single time you have a term inside of the parentheses, that's the number of little umbrella loops that you're going to be drawing. So 3 times y is 3y. 3 times 2 is going to be 6, but don't forget that negative in the middle. Make sure that sign goes with it. And that's all. This is the answer. That's all distributive property is. And again, if you're someone that likes the visuals with the area models, you're more than welcome to draw your area models if it helps you. I mean, the minus is a little strange, but the idea is still there. Now we're just adding, we're upping the ante a little bit with 3 terms. So how many loops do you think is going to be with 3 terms? 1, 2, 3. So 5 times 2x. So 5 times 2 is 10x. 5 times 2y is going to be negative. Remember, the sign stays right now. 10y. 5 times 4 is positive 20, and that's it. They're all unlike terms. If they were not, if there were like terms in there, then you would simplify that first. Condense, condense, condense. All right, how about you try these on your own? And then maybe like pause the video and see if you get the same answers. All right, welcome back. So let's see if you have the same answers. 9x plus 36. And you should have these little loopies on yours, okay? 6y minus 8 plus 10x. Eight x minus 56. 6x plus 27. Not so bad, right? And now you have more you tries. This is on you. You can check your answers on Monday with me. Short and simple video. All right? All of these problems need to be done by Monday. Monday. Bring it back. Bring it back on Monday. Bye, everyone.